Of course, there are certain problems that a computer can't solve. It can't appreciate the beauty of a painting, for example. A computer cannot predict the outcome of a soccer match, at least not accurately. And of course, a computer also cannot see into the future and tell you the lottery numbers of next Saturday. So at this point, we have to start off a little bit more formal and specify exactly what kind of problems we are talking about and what we mean when we say we want a computer to solve a problem for us. And we will do this through 3 requirements. These requirements might seem very obvious to you, but later on in this unit you will see that these requirements actually have some very, very important consequences. So the laws of computer problems. Rule number 1 for a computer problem: the input must be given to us as a finite string using a constant number of symbols at each position in the string. The input for a computer problem could, for example, be a number of zeros and ones. It's not infinite, so it has a defined end. And by constant number of symbols, I mean constant number of symbols at each place. So in this case, at each place in the string, we either have a 0 or a 1. Here we could have a 0 or a 1. Here we could have a 0 or a 1, and so on. You could also have a string like this. Again, it's finite in length. And this time we're using the real alphabet. So it doesn't really matter what kind of symbols you use, as long as the number is constant. And that is basically the same requirement that we already had when we discussed the RAM, because for the RAM we also said that at each memory cell we could only have a finite number of symbols, so no variable can become arbitrarily large. And the same thing is here, we cannot use an arbitrarily large alphabet at each point in the string. Rule number 2 is exactly the same as rule number 1, with one exception. Instead of input, we write output. So we also want the output to be given as a finite string using a constant number of symbols. Actually, we could even restrict ourselves to decision problems here, but we're going to keep it general. So you give the computer a string and you expect it to output a string. And then finally, rule number 3. Is that going to be as surprising as rule number 1 and rule number 2? Yes, it is, because rule number 3 is going to be that if we get an output, then we want that output to be a correct answer to our problem. And that is one important point, an answer where we can objectively say that it is correct the moment it is given to us, and it is supposed to be definitive. So we do not want the computer to say, oh, let me work on this for a little bit longer. When it produces the output, that's supposed to be the answer.